Asdale, and I am the lead SE for the United Kingdom. Today's subject is reimagining legacy information management and protection with the StorageCraft OneBlox system. And we're going to run through a presentation and introduce the technology that we're talking about today. And then what we'll do is we'll have a brief look at the interface, the user interface of the OneBlox. If you have any questions during the course of today's webinar, please feel free to use either the chat window or indeed the questions pane on the GoToWebinar windows. With that, I think we shall just kick things off. So, as I said, we are today talking about the StorageCraft OneBlox, and we're reimagining legacy information management and protection. The first thing that we need to look at is the current limitations that are associated with RAID scale-up storage. And very simply, that most people, when they come to buy storage, are looking at a product lifecycle refresh, which generally will require someone to effectively guesstimate how much storage that organization is consuming currently, but also guesstimate exactly how much they will require in 3 to 5 years' time. Now, normally at this life cycle, it's a rip and replace, which means that that organization needs to consider a particularly heavy capital investment to be able to buy a lot of disk and hope that they have been able to correctly guesstimate the amount of capacity that will be required during the 3 or 5 year life cycle of that piece of storage. Now, most people do get that wrong at some point. The other problem that we have with this kind of legacy model is that the controllers in these units have got a fixed performance and availability, and the usual model is that we have a master node with other pieces of storage daisy chained off the bottom, which will then point at us having a potential bottleneck, and that bottleneck would be the master controller or the master node. Now, this is the legacy model, and this is not what we want to allow people to do. Instead, we want to move forward to almost a pay-as-you-grow model. So the answer here with Exablocks or with OneBlox, is to eliminate the guesswork. What we want to be able to offer is the ability for people to start with the amount of capacity that is required, and then organically, incrementally increase the capacity that is required as it is consumed. And as such, what we talk about is the ability to scale out, not scale up, we're talking about scaling out. So we have the capability for then users to be able to add additional disks to existing units, add additional units, and that will increase the performance as well as the capacity and availability, because each of these units connects directly into the network as a single entity, and that's a single physical entity, but managed as one single solution, regardless of how many units. This will allow people now to be able to provision the storage resource that is required when it's required, as opposed to buying 5 years worth of disk up front and hoping that you got the sums right to begin with. Now, the way that we're able to perform this is using our unique scale-out architecture. So on this slide here, what we're looking at is the traditional architecture of block storage. The block storage historically was then provided via a block protocol, so something like Fiber Channel Protocol, or served up via iSCSI. And it was a simple methodology of being able to present the blocks as they are stored on the disk. The other option here would be through traditional NAS storage, which would use almost an abstraction layer of file and folder to present an SMB, NFS, or SIFT share. And what that would present would be the file and folder architecture, but underneath that, everything was still being written and served up as blocks. And moving forward, storage is moving away from block storage and it's moving to object stores. And there are 2 ways that we can perform this, or that object stores can be presented. Now, the first one, which is the third column along, is using RESTful APIs, and that's giving the capability of an object store that can actually be read and written to directly from the pieces of software that are utilizing it. So if we look at something like perhaps an S3 server environment, using a RESTful API, it would be possible for the hypervisor to actually read the VMs directly from the storage without having to utilize a protocol to be able to understand that traffic. And then the fourth column along is what we're presenting and what we're offering today to the market. And it is the capability of an object store with the intelligence of an object store. But just to make it a little bit simpler and offer it to a wider market, we are layering over our object store an SMB or NFS share. So we will present to the market or to your environment a very simple share, so a file and folder hierarchy, but everything within that will actually be written and presented as objects. So, question quite often is, how does that work? How does it actually work in that methodology as opposed to traditional NAS with an object with block storage? And it's very simple. What we do is we're presenting that file system as a service. So underneath the file system that is being seen via NFS or SMB, we actually hold a contents addressable objects, which are then identified and tagged. So there's an ODI for every object, and you can actually search for those. So it's fully content addressable. And then underneath the individual objects, we have our object store, which is a distributed object store, meaning that we can manage in an intelligent methodology the capability of having multiple locations in either an N+1 or N+2 method to make sure that there's the capability of handling persistent reads, as well as the ability to continue to serve up that information, that the data that is being requested in the event of any single disk failure. So that's what it looks like under the tin. That's the technology that we are utilizing to be able to present scale-out NAS using an object store. And the way that it's all managed is through the OneSystem itself. So the OneSystem is the management interface, which can either be installed as a VM for private cloud environments, or more typically, it's actually being managed over public cloud. So most of our clients today are logging into onesystem.exabox.com, which gives a single point of management for any number of units that can be distributed locally or worldwide. And it gives you that single management pane for every single one of those units. To be able to access this, you sign up with it, with an email address. So we have our 24/7 proactive monitoring, which means that if there are any alerts that are kicked off, they're actually emailed automatically by the system straight to the email address that was used to register that account. Through this, we then have the capability to actually go in and view the health and the status of the hardware, identify what is going on, see if there are any problems. We can also look to make sure that there aren't any predicted smart failures on any of the disks. And it's also where we then manage the powerful replication capability that comes with Exablox, OneBlox. It is zero configuration for then scaling this solution by adding another OneBlox to the environment. It's very simple within this actual management interface to then add that to an existing cluster or ring, as we call them. And then once that has been performed, the actual OneBlox system will automatically distribute the data to ensure that that object store is being managed intelligently. In terms of the replication, we'll have a look and I'll show you how to do that when we break out of the presentation into the actual management interface and show you just how simple it is to enable a replication. And we also have the capability to provide lights out management, both via the OneSystem. We also have a web console that can be accessed locally for the individual OneBlox units, and all of these units also have a remote management card, which means that you can actually dial in and have a look at what's going on and manage that remotely as well. So there is no requirement necessarily for any on-site presence. So this slide here is just to effectively identify and display the hierarchy, or failure domain hierarchy, where we have from a single disk drive all the way up to a OneBlox node, to OneBlox clusters, to OneBlox replicated clusters. And the reason that we put this in here is effectively to explain to you that as the stress level, the amount of stress that the disk is increasing, it goes up, we are effectively showing the capability to be able to recover from any scenario, from a single disk failure to a node failure within a OneBlox cluster, and then the capability to experience entire cluster failure, but still be able to replicate, or still be able to recover from that with our replication. So we're able to preserve the user's data and ensure that there is availability of that data, regardless of the type of failure event that is experienced. We do this with our kind of unique next generation storage solution that the OneBlox provides. So we're providing scale out storage, which we've explained. Every single piece of data that's written into these units actually experiences inline deduplication and compression. So immediately you can start to consider footprint and disk space savings by utilizing one of these devices. We offer a continuous snapshot methodology, which does not have to be manually managed. You don't have to consider things like snapshot reserves. You don't have to identify a snapshot schedule. All you need to do within the OneBlox is to tell us how long you want to keep snapshots on each individual share. This is a completely RAID-less data protection. There are no logical unit numbers. There's no LUNs in this environment. We're going to utilize every disk that is in the OneBlox unit, and we're going to distribute that object store across those disks in that single unit, and then distribute the objects across the object store across all of the nodes within the cluster to ensure there is a capability of being able to recover from single or dual disk failure, or indeed in a fully populated cluster, we can actually recover from multiple OneBlox node failures. This is a very strong solution to help recover from any disaster. So it's a very strong disaster recovery capability, and the basis that we can offer that optimized replication to secondary location, as well as our current certification with most of the major backup vendors today. So if you're looking for the capability to improve your existing third-party backup software, then the OneBlox gives you the capability to not only manage that backup data more intelligently, but also to reduce the storage footprint whilst doing that. The other thing that we quite often talk about is that this works on almost a bring your own drive model. So you can then purchase a unit and then have simply 3 drives in it to begin with, but add drives one at a time at standard retail pricing. That's what gives us a bit of an edge over some of the competition within this object storage space, and it's the capability to be able to look at an enterprise class object store, but at a mid-market pricing model on the basis that we're not going to take delivery of a drive, format it at a proprietary sector size, install our own firmware, and then hike up the price by, times 10. In terms of that data protection, as I've said, with our distributed multiple copies of your objects, we can recover from 2 drive failures within a single unit, and we can recover from any 2 OneBlox nodes within a 3-node or higher cluster. There is automated dynamic copy and recovery, so if you then were to replace the failed drives, because we have that distributed object sector, we will direct reads of the objects to one location whilst we perform the write to that replaced drive without suffering an impact on the actual performance. With this ability to add individual units one at a time uniquely, we are truly offering the ability to scale not just the capacity but the performance and the resiliency as well. The product in question on this slide is our OneBlox 4312, which is the capability of housing up to 12 3.5-inch hard drives, currently supporting 1 to 8 terabyte hard drives, so that could be up to 96 terabytes raw. The beauty of this bring your own drive model is that you can mix and match SATA and SAS, as well as the capacities within a single OneBlox, and it will still function. In terms of connectivity, whilst we're talking about presenting a file share of CIFS or SMB, NFS or SMB, we can offer both copper and optical connections, and we're looking at 1 or 10 gig, and again, redundant links. The second model that we have within this portfolio is our OneBlox 5210, which is an all-flash scale-out storage. This gives you the benefit of being able to scale to increase the capacity required, but also at that point to increase the performance. So this is a perfect unit to be able to address both a capacity and performance challenge within an environment. The OneBlox 5210 is the exact same software underneath. There's nothing different. The main difference here really is the fact that we're talking about it being all flash in a 1U form factor. So today it's currently capable of handling up to 10 2.5-inch drives. Again, you can mix and match SATA and SAS, 12 gig per second drives. We're supporting, as you can see, any Samsung and Intel TLC and MLC solid state drives up to 4 terabytes. So again, customers are starting to enjoy the SSD price declines, as they're now starting to actually decline in price eventually. But from a single unit on this model, we're able to provide 50,000 IOPS. Hopefully you'll start to see the benefit of being able to look at, and the way I would really describe this is, you can look at the performance of an all-flash array at a price that's actually capable for the mid-market. Okay. At the moment, with this 10 SSDs, we are looking at industry-leading storage density. So across our cluster of 7 OneBlox today, we would be looking at 280 terabytes raw per cluster. If we can achieve a 5-to-1 ratio of deduplication and compression, which when we're talking about enterprise-class variable length deduplication and compression, 5-to-1 is not out of the question. In fact, in some environments, I've seen upwards of 20-to-1 ratios. But if an assumed 5-to-1 ratio, we would be looking at 700 terabytes effective storage per cluster, which comes in at 40 cents per gig of all-flash storage. I can tell you that you will struggle to find anybody that can offer that type of price point across the market. And again, as I said, there is no difference really, other than that this is an SSD model. Again, it's served up with NFS and SMB network protocols. So we're again looking at SFP Plus or GBIT connections of 10 and 1 gig. Okay, really the perfect positioning for these OneBlox units come across these 3 sectors: data protection, virtual servers, and unstructured data. So what we're going to do is we're just going to have a look at each of these in turn to explain the area that we feel that we can offer value to existing infrastructures. So in terms of data protection, we have the capability to offer heterogeneous OneBlox multi-site replication. We can do many-to-one, one-to-many, bidirectional, multi-hop replication. This means now that for the customers out there who have mission-critical data that has to exist in multiple locations, it's a very effective way of being able to offer that, but at a much more intelligent manner, where we can replicate an entire share from, in this example, from Denver up to San Francisco. We could have San Francisco and New York replicating to each other, and each of these shares is now capable of not only existing in 2 locations, but if one of them fails, we can actually promote that secondary share from the second location, and all of a sudden those copies become read-writable. Whereas before we enable that failover or that promotion of a replica, it sits in read-only mode. So there is very comprehensive data protection, and as you can see here on New York, we have engineering share, we've got a Veeam share and a VMware share. As I said, don't forget that we are certified with the majority of today's industry-leading backup software vendors. So this is a prime example of being able to offer a more intelligent backup and disaster recovery capability, with looking at simpler management as well as massively reduced storage footprint. Then we have our capability when it comes to virtual servers. Now, all of our units are certified as VMware ready, and they're also certified with Microsoft Hyper-V. So, as we can see, a OneBlox NFS data store has no capacity restrictions at all. So an NFS data store existing on a OneBlox is capable of supporting as many VMs as you could potentially look at. Probably most of us on this call today understand exactly how simple it is to increase the size of a VMFS through ESX. So in terms of being able to scale your actual repository for your VMs, it's an incredibly simple thing to achieve when you're looking at storing your NFS or your VMFS on a OneBlox. In terms of capacity, as we can see, can be added in minutes by either adding additional solid state drives, because again, don't forget, none of these units have to be purchased with any preset number of drives in it. So you can simply just add SSDs or add OneBlox units as they're required. There is absolutely no storage reconfiguration required. There's no application reconfig, there's no downtime. All of the capability of being able to add additional storage is managed through the OneBlox and through the OneSystem, which will then perform automated distribution of the data in the background to ensure that you don't experience any degradation in performance while that's happening. We're also very strong when it comes to VDI environments. So 5210 cluster, we can store the VMs in the VDI images. We could have a couple of 4312 cluster hosts and all of the files. So traditionally you'll have your golden image and you'll have your guest VMs, but all the files will sit on a file server somewhere. So we can have all the files sitting on a 4312, which is more designed for unstructured data. And then the OneBlox cluster can also then be remotely replicated for disaster recovery, so that if, God forbid, you lose an entire site, you still have copies of all of the user files, as well as the ability to spin up the, perhaps if it was sitting on the chunkier units, to spin up the number of VDI or number of guest VMs that are required. So it's a very strong solution for VDI environments. And then finally, we talk about unstructured data. So when we talk about the scale-out cluster for individual applications, we do have that ability to be able to determine whether the deduplication that is run on that share is variable or fixed length deduplication. And the purpose of that is to determine the response time. Obviously, there will be certain environments that will experience better ratios of fixed length deduplication. These would traditionally be things like a VM environment, because ESX utilizes 1 meg blocks, so that will always perform better at fixed length deduplication than variable. The compression can be turned on and off. We cannot turn off the deduplication today. That is one of the strongest features of this unit. So you do have the capability to determine whether it's variable or fixed length, but it cannot be turned off. In terms of the data protection, when we talk about our snapshot mechanism, our snapshots run automatically every 10 seconds. What we do is we capture the changes of our objects. So it's an incredibly lightweight snapshot mechanism. All you determine is whether you want to retain the snapshots and how long for, and again, that is all managed per share. And then remote replication is all per share as well, so it's very simple. Again, in a wee minute, we're going to break into the actual user interface and we'll have a look at the capabilities there. So what we're offering here then is simple scale-out capabilities to enable the immediate provisioning of storage for multiple purposes. So you can see in the diagram underneath that we started off perhaps with a 4312 that was just provisioned as a file server, so it was perfect for the unstructured data. But then, moving forward, as this organization has required additional capacity and they've seen the benefits of using the OneSystem, the OneBlox, they've decided that they're also going to invest in perhaps some 5210s to house their VM repository, as well as an increased requirement of capacity within the file server. So they simply add another couple of units to that cluster. And then again, moving forward, we then decide that we're also going to append the VDI clone in there. We've increased our file server, we've increased our VM repository. This is an unbelievably simple to use piece of hardware. And the beauty of it is, as well, is that if we think back to the original, when we talked about the guesstimation and the life cycle of a OneBlox unit doesn't really require any consideration, because it's as simple as going into our OneBlox system, evacuating the data from a single unit that may be at the end of its usable life. What that'll do is it'll make sure that there are still redundant copies of the objects as well as the database across all of the remaining nodes in the cluster. Simply remove that unit from the cluster, add the new one. And again, because it's unbelievably simple to add additional storage to an existing cluster, we would simply add that new unit to the cluster, and the system will perform this automatic redistribution of the data. So all of a sudden, forklift upgrades and things like that, rip and replace, these kind of terms, they do become redundant when we start to talk about OneBlox. In terms of how we provide the shares, we don't require a Windows server running, consuming any disk space. We will present the share directly, broadcast it directly onto the network. We have selected directory integration so that permissions can be set through your AD server. You can then perform things like SMB share level quota limits, and you can perform you can access hidden SMB shares with the access based enumeration. And again, as you can see here, we will look at this. We have the ability to custom determine how long we customize to determine how long we retain those. Now, one area where we're starting to see quite a bit of success on the market is in the ransomware, or recovering from ransomware. Because of this continuous data protection, where we talk about, or near continuous data protection, where we talk about taking a snapshot every 10 seconds, when we take those 10 seconds, and that is every 10 seconds and retained for the first hour, we actually make those snapshots immutable, which means they cannot be encrypted, they cannot be overwritten. There is nothing that any piece of ransomware can do to actually infect those files or infect those snapshots, which means that in the event of potential ransomware attack, our users simply need to just rewind to a previous snapshot, undo the changes in the objects, and return the objects to the status that they were prior to the attack. That also gives the capability then to look at recovering individual files or folders, or indeed the complete share, because we will actually provide access to that through the previous versions within Windows, and we can also offer that through a Mac environment as well. So at the moment, I'm just going to have a look and see if we have any questions. I believe we did. How stable is the network connection? Some skeptics say that such tech will drop off the network at the worst of times. This is only the case with object-based stores. Okay, so good question there. Right, okay, so German asked the question regarding the network connections and effectively the stability of that. German, just to let you know that through all of the POC environments that I've looked at, as well as the units that we've sold in the UK, I haven't seen any problems with our network connection. I would say we're looking at, effectively a lagged connection across, either 4 1 gig connections. So again, as long as we can enable LACP at the switch, then we're looking at potential of up to 4 gig incoming on a 1 gig network. SMB can sometimes be a slightly chatty protocol. NFS is absolutely perfect, but I've not seen any problems with connection drops, German. So yeah, I would suggest that this is probably a worry of from skeptics that have invested in perhaps lower grade technology. And David is quickly asking, what are the key technologies that this would compete against? Now, that's a very interesting question, David. So just to give you an idea, that At the bottom end of the market, we kind of see devices like QNAPs and Synologies and so on. And without trying to sound like I'm doing them a disservice, we call them cheap and cheerful, because they offer block storage. QNAP actually can offer an object store, but yeah, they're offering cheaper storage that is, very easily consumable. What we're looking at doing here is offering an enterprise class feature set. When we talk about our enterprise class variable length deduplication, the snapshot mechanism, the one optimized replication utilizing dedup compressed snapshots, I would suggest that we are looking at people that are probably looking at 20 terabytes of data or above, not necessarily, but dependent on the price point. That's usually a starting point. In terms of who we compete against, we're seeing a lot of success competing with NetApp. In the UK specifically, I've spoken to quite a few customers who are getting to product life cycles on pieces of kit like Synology NAS, Isilon, EMC Isilon, where we are able to offer a very similar product set, but at a massively reduced price point. NetApp is a good example because you can achieve a distributed object store with NetApp, but then you need to consider multiple NetApp nodes, multiple NetApp headers. You're looking at active sync, you're looking at SAN mirroring, and it becomes an incredibly expensive proposition. In terms of where we compete, I would suggest that there are specific verticals that this will fit into much more easily. We are seeing quite a lot of interest coming from the public sector, and specifically education, further education. We've had interest from multimedia companies, and also the research sector is seen to be very interested, where we're looking at environments where there is a lot of data being created and a lot of large and a huge number of files being created in the day-to-day operation that don't necessarily require to be looked at particularly much thereafter, but they need to be created and they need to have somewhere to live whilst operations are ongoing. But I would suggest, David, that we need to start above the low end of the SMB market. So we're not going to compete against a Synology. We're not going to compete against a QNAP, because quite simply, on price, we're not offering something that's similar. It's not apples for apples at that point. What we can do, David, is if you would like to have a further conversation or have a one-on-one conversation at any point, then we can simply arrange a session to have that chat. Okay, so what I'm going to do is I'm going to break out of this presentation just now, and I'm going to have a look at the OneSystem. So here we have the OneSystem logon. So it's onesystem.exablocks.com. I can log in here. Hopefully my hotel's Wi-Fi connection is good enough to get me there. Okay, come on. They do say it would only ever be a real demo if something didn't work as quickly as you would expect it. And there we go. So as you can see, I've got multiple organizations that I can look at. I'm going to click here on my StorageCraft EU. And what that's going to do is it's going to present to me with the clusters that I have available for this organization. And just to let you know, on that front screen, there is theoretically no limit on how many organizations you can look at the management of. Here I've got two clusters. I've got my StorageCraft EU and my Replica EU. So if I, again, just click on StorageCraft EU, it'll take me in and it'll start to give me some information now. So we can see here that I have a single node that is running within my cluster. Today, just to let you know, the upper limit of of units within a single cluster is 7. By the midpoint of next year, we'll actually have increased that to 21 nodes. So you can start to see the true growth capability, and that would be 21 nodes, just to let you know, sharing a single namespace. So whilst we can have as many clusters as required, for example, if you had 3 namespaces, each one of those could be spread across a 7-node cluster. The limitation is of a single namespace across a 7-node cluster today. So this is a test unit. If I want to understand a little bit more than just the used capacity and current dedupe and compression ratios, I can click in on the unit itself, and it'll take me into the health page here, where I can see that I've got 4 drives populated. Now I can actually have a look over these. As you can see, there's access to monitor, to have a look at the smart monitor. We can find out the smart health disk, what type of disk, what model it is. I've got, as you can see here, I've got across my Ethernet connections, I am using LACP, so I've got a bonded connection. There is, just to let you know, it's automatic bonding takes place. So if you can start off with 1 network cable attached, simply to get it on the unit, and then get it on the network, and then you add an additional 3, we'll automatically add those to the bond for you. See how many we've got. Okay, and then we've got our MAC addresses for each of our ports, and the IPMI is not connected. If we go back then to StorageCraft EU, some of the things we can do within this organization is to look at adding users. So if we want to add someone, now just to let you know, this unit is actually sitting in workgroup mode. It is not connected to Active Directory, so I don't have the ability to add any AD permissions. But if I want to add someone here, it's as simple as just clicking Add User and then going through this. Are they a user, the admin, are they a delegated admin? So perhaps you have someone else looking after the storage for you. Do we have any members, friends and external users? What access do we want to give them? It's very, very simple. In terms of shares and exports as well, it's, it really couldn't be easier. We want to add no shares to display. I could quite simply add a new share here. This share, put this on the StorageCraft one. We'll make that an SMB share, and we're going to give everyone access. Now, this is interesting. When we talked about the share management, we do have some kind of predefined policies. So for VMs, we turn off the snapshots because the expectation is that you'll be using some kind of hypervisor snapshotting. Compression has been enabled, and the deduplication is fixed length. As I said, we do look at the ability to operate not only a faster but an easier way, or sorry, a more efficient way of deduplicating when we're looking at a fixed length on virtual servers, because they use 1 meg blocks. So then we've got backup and recovery, snapshots are on, compression is on, and deduplication is variable length, because we want to add as much of a storage and a space saving to backup footprint as is possible. Now we've got our default, but what we're going to do is look at custom, and this is where I advise that we've got the ability to determine how long do we want to keep these snapshots for. Do we want compression on? Do we want fixed length, or do we want to turn it on to variable length? It's all very, very customizable. So what I'm going to do is we're going to go for backup and recovery, and we're going to save that. Okay, so now if I go back into my shares and exports, I'll log in back in. I'll look into show me them because it does. Load them up. There's probably quite a large number of them here. I just need to find my test share. Test share, there it is. Okay, so if I wanted to enable replication of this SMB share that I've just created, I simply select it, we come up to actions, and we could say replicate. Now all I need to do is identify my replication target, which has already been set up. Next. And if we need an external port, if we need to identify it with the external IP addresses, generally things that would already have been configured, I can simply hit finish. And that's how difficult it is with this piece of software, with this piece of hardware and management software to achieve replication, so the disaster recovery capabilities. Other than that, we have within this environment, we've got reporting, so we can start to show the deduplication as it should hopefully increase the more the unit's used. In terms of performance, we can look at network I/O, disk I/O, CPU usage, things like that, memory usage. Yeah, it doesn't, to be honest with you, I could try and make it more complicated to I don't know, to try and show that there's more to it, to be very simple and make it very simple. This is a piece of storage technology that gives scale out capability using a distributed object store, so that you've got advanced redundancy in the event of suffering disk failure or indeed site failure. We've got the optimized WAN replication so that we can recover from full TR. We've got the automatic snapshotting, but without the requirement of losing, 20 to 30% of your expensive tier 1 storage. Because we've got the two units, the 52 and the 43, and these can be mixed in a cluster, the way I would describe this is it's the next generation of object storage, and what we're doing is we're blurring the lines between tier 1 and tier 2 storage. There's not really much more to it than that, so I've currently taken 42 minutes of your time. I'm going to just keep the line open. I don't have anything more to tell you, I'm afraid. So hopefully there may be some further questions. Feel free to use the question pane. Feel free to send a chat. David, you'll see I've just put my email address on screen there. So if you don't mind sending me a quick email, what we'll do is we'll pick up and have a conversation at some point. I'm on the road today, so I'll be driving home later on. I can give you a call if you want to email me your number and we can have a chat. Unless then there are hopefully any other questions from anyone else. James Dyke has come in to muddy the water. Thanks, James. That's not related, but any update on 6.7 SPX? What I would say is watch this space, James. We've ironed out, there were a couple of outstanding bugs on it that have been ironed out. We're looking at a select customer beta at the moment. As long as that goes successfully, then we'll be releasing it as soon as we can. What's the availability on evaluations of trial units? You're based in Dublin. Let me just have a quick look at who we've got here. Gerard Foley. Gerard, if you don't mind contacting David Flood for me, we can have a look and see, David, at what we can do to try and support your request there. We do have a small number of units in EMEA, so we might just have to put you on the waiting list, but we'll have a look and see. So, Gerard, if you don't mind taking that action away, I can see you're paying attention, so there's no excuse. Any other questions at all? Any more for any more? You're very welcome. Okay.